Hai, apa kabar teman-teman? Jumpa lagi di YouTube channel Mikrotek Indonesia. Oke, kali ini kita agak sedikit berbeda ya. Kalau teman-teman yang sudah sering sekali join di YouTube channel Mikrotek Indonesia, biasanya kita live streamingnya jam 1. Nah, kita agak geser sedikit nih jamnya jadi jam 2. Memang ada alasannya ya. Kenapa? Karena memang kita akan kolaborasi kali ini ya. Akan kolaborasi membahas mengenai wireless ya. Sebelum itu buat teman-teman yang baru join, baru tahu mengenai channel Mikrotek Indonesia, jangan lupa untuk melakukan subscribe dan juga jangan lupa untuk klik tombol lonceng supaya teman-teman dapat notifikasi mengenai acara-acara yang kita adakan, contohnya seperti ini. Dan kali ini memang saya sendiri, nggak ditemani. Nggak juga ya, saya ditemani oleh alat-alat ini ya. Ada di samping kanan kiri, alat-alat ini adalah alat-alat yang sangat luar biasa. Mungkin aneh buat teman-teman, ini alat apa gitu ya, baru lihat gitu itu ya. Yang jelas ini adalah perangkat-perangkat yang bisa membantu teman-teman supaya instalasi wireless teman-teman mungkin bisa lebih optimal. Dan mungkin teman-teman juga bertanya, apakah ini teknologi alien? Mungkin dalam pembahasannya nanti mungkin bisa dijelaskan bahwa ini teknologi alien atau bukan. Ya. Jadi stay tune di channel Mikrotek Indonesia. Sebelumnya saya ingin menyapa teman-teman yang ada di YouTube. Oh iya, streaming kali ini di channel Mikrotek Indonesia ini agak berbeda. Kita akan collab tadi, saya sudah sebutkan. Yang kedua, kita juga membuka interaksi lewat Zoom. Ya, jadi teman-teman bisa pilih mana ya, bisa menggunakan Zoom, bisa juga menggunakan YouTube, nonton di YouTube. Jadi terserah teman-teman enaknya atau istilahnya lebih nyaman menggunakan platform yang mana. Lebih seneng YouTubean sambil tiduran atau bisa juga di depan komputer sambil Zoom. Nah, enaknya di Zoom nanti teman-teman bisa langsung interaksi, bisa melakukan melayangkan pertanyaan. Nanti ada tim dari Citraweb juga yang akan membantu teman-teman jika ada pertanyaan. Buat teman-teman yang sudah di YouTube, siapa aja nih? Udah banyak nggak? Berapa banyak nih yang nonton? Sudah 1 juta penonton, enggak ya? Bercanda. Ada teman-teman dari Medan, ada dari Malang, dari mana nih, Kendal, Jombor. Wah, Jombor mah deket sini ya. Perempatan Jombor ini, enggak ya. Oke teman-teman, terima kasih sudah meluangkan waktu walaupun jamnya berbeda, tapi teman-teman tetap setia untuk nonton di channel YouTube Mikrotek Indonesia. Dan memang untuk event kali ini kita akan membahas mengenai wireless dan kita kolaborasi dengan istilahnya core of the core-nya lah. Teman-teman yang memang punya keahlian di wireless. Dan kebetulan kita ajak teman-teman dari RF Elemen dan mereka ini jago mengenai wireless dan mereka membuat produk-produk yang luar biasa. Memang konsentrasi mereka di wireless. Jadi teman-teman yang punya pertanyaan, punya masalah dengan wireless, teman-teman bisa tanyakan ya hal itu. Jadi ini adalah kesempatan teman-teman untuk menggali banyak informasi, untuk banyak belajar mengenai wireless. Nah memang teman-teman mungkin banyak bertanya bahwa kenapa pakai wireless gitu ya. Padahal sebenarnya kan sekarang enakan pakai fiber gitu ya. Mana-mana mau ke rumah koneksinya pakai apa? Pakai fiber gitu. Kalau nggak pakai fiber katrok gitu istilahnya. Padahal sebenarnya dalam kondisi-kondisi tertentu kita tidak bisa menyelesaikan semua permasalahan di jaringan itu menggunakan fiber. Ada kondisi-kondisi tertentu yang tidak memungkinkan kita untuk menggelar fiber. Misal untuk daerah-daerah yang jaraknya jauh, untuk pemasangan fiber itu biayanya cukup mahal. Nah teman-teman masih bisa punya alternatif lain ya, yang bisa digunakan untuk mendistribusikan jaringan Anda, jaringan teman-teman, yaitu menggunakan wireless. Jadi wireless ini sebenarnya sudah cukup lama ya, sudah cukup banyak digunakan sejak tahun berapa ya? sejak tahun 2000-an awal, 90-an akhir itu sudah banyak ISP yang memanfaatkan teknologi wireless ini gitu ya. Nah, kita akan coba menghubungkan atau istilahnya kita akan coba sapa teman-teman dari RF Elemen. Apakah sudah hadir di sini teman-teman dari RF Elemen? Guys, are you there?
Hey, hello.
Wow, hello bro.
Hello, good morning and good afternoon. How are you guys?
Yeah, we are good. So thank you for your time. It's be honor to us to you can join this so we can collaborate with such event that maybe people in Indonesia very interested with this kind of event. So how life's there? How life's
Everything
there?
is okay. Everything is okay. Under the COVID, but surviving.
Okay, so yeah, we also have some problem with COVID situation here, but luckily we can stay healthy here. We can work normally here. So you work from home or in your office right now?
We are now in the office.
Oh, we're
Yes.
in the office. Okay. So we will talk about wireless and maybe we will have a lot of questions about wireless, right? So
Definitely.
yeah.
Questions are always good.
So we so especially I will not wasting my time here, and maybe we will focus on your presentation, and then maybe so how long your presentation will be?
Presentation will be approximately 45 minutes.
45
1 hour.
minutes or 1 hour, right? So
Yes.
we have plenty time. But how about if anyone want to ask a question? So
Yes.
we can do flow within the presentation, or you want to make it like a special session for the question?
We will, at the end of the presentation, have a space dedicated for answering all the questions.
Okay.
So people can write them during the presentation, and then at
Okay.
the end, we will reply to them.
Okay. So basically, my team from Citraweb also joined the Zoom to collect all the question, and my team also in YouTube also collecting all the questions. So we will summarize all the question that still related with this topic, right? So maybe I will ask a question visit from the summaries. Okay, and then,
Perfect.
So it's time for you.
Perfect.
Yeah.
I will share my screen, please, and you will let me know.
Okay.
Okay. Okay, can you confirm, please? If you see the screen with the...
Yes, we got it.
Okay, perfect. So, okay, so if the screen is properly shared, so let's start with today's presentation. Thank you first very much for this opportunity to participate in a joint presentation event with Citraweb. It's really an honor for us also have the opportunity to share with you and with the rest of your clients. So first of all, good morning, good afternoon, depends on where you're located, to everyone joining us today in this live presentation. First of all, thank you very much also for assisting this presentation. Today we will be covering a really interesting topic. But first, my name is, as you see on the screen, it's a very long name, so I will just shorten. My name is Jorge Fernandez, and I'm product manager also here in RF Elements, taking care basically of Latin America, but also of things that come out in the English language. So today, as I was telling you, we're going to have a very interesting presentation. We're going to be speaking specifically about how to achieve the noise rejection with RF Elements horns. I'm pretty sure this will be a topic that many people are interested in knowing more about. So without any further delay, let's just start with the first slide of this presentation. So at RF Elements, our main goal is to help the WISP thrive by enabling them to run stable and also fast wireless networks through our noise rejection technology with near zero loss connection, as you can see on this slide. The noise rejection is a stepping stone towards massive scalability of wireless networks provided by our wide range of antennas, which we offer in our portfolio of products. So this kind of spectrum analysis is what many WISP see when they are running their networks today. So this is basically the problem they're facing, which is RF noise, which is limiting what they can do in with their businesses actually, and at some point it also it limits them the ability to grow and also to keep their business working or staying alive, let's say this way, altogether. So this is a really the key challenge we have identified in what WISP are facing today, which is a very, let's say, a tough problem to face. So the problem then is that the spectrum is, as we know, is a limited thing that we can use. And therefore, we should think on how to keep it well preserved as one of the most, let's say, valuable resources that the WISP operator have in their hands. The main cause of this spectrum congestion is the huge amount of technology that has been deployed for years, which became, meaning the very advantage of this unlicensed frequency band, meaning that anybody can use it, became also the biggest problem for everyone, or the downside. On top of that, the devices that were deployed for years and years and years were based on a technology that was directly adopted from other industries, which is unfortunate because the patch array antennas are completely unsuitable for WISP who want to operate stable in the unlicensed networks. So the main issue here, once again, is the antenna side lobes, which are almost never mentioned, as we know, when talking about antennas. So people usually, what they do is they talk about a gain, they talk about beamwidth, and perhaps front to back ratio, which is another metric or another parameter that people usually speak about. But people do not speak about the side lobes, which are the root cause of the problems with noise in the unlicensed WISP networks. So let's take this, for example, the antenna, the omnidirectional antenna. This antenna, as we know, it radiates equally in all directions in the azimuth plane and nothing in the vertical directions, making its radiation pattern kind of like a donut. So omnis are let's say, the least sustainable or suitable antenna in unlicensed bands, since they spread the signal everywhere and receive also the signal everywhere. When I mean everywhere, I mean the full 360-degree circle. For vast majorities of the WISP scenarios, when they deal with different positions, this is probably the worst antenna they can use, since it pollutes the spectrum in every direction and also makes any network extremely sensitive to any noise sources in the area where it's currently deployed. Patch array antenna, these are antennas that cover a sector of the whole azimuth circle. So a typical radiation pattern of a patch array antenna will look exactly like it's on the screen right now. So nevertheless, their side lobes, despite being quite a bit smaller, that the main lobe can cause problems with noise, as we know already. On top of that, the size of the side lobes and therefore the performance of the antenna as such changes with the frequency, which is extremely undesirable feature. The frequency dependence of the radiation pattern causes that the RF radio will see different spectrum, so you cannot really rely or, let's say, trust this antenna. So you'll see the same performance when you switch to channel. This makes the networks using patch array sectors like a house of cards. Basically, we are standing in something that even the slightest change can throw the whole network off, making your life really difficult. These antennas are commonly used for point-to-point scenarios. They have also many side lobes. The physics of these antennas dictate that we cannot fully avoid these side lobes. The result of a dish having side lobes is the same as patch array sectors. But so the side lobes collect and transmit at the same time noise from unwanted directions, eventually showing up as a slow network and leave the people scratching their heads, wondering where is the 1 gigabyte of the throughput that the radio manufacturer declares on the datasheet. And the problem with side lobes is basically causing, the consequence is causing high noise levels in WISP networks by multiplying with growing number of sectors in a specific tower. So the side lobes of the neighboring sectors interact with each other, and despite that all the devices might be your own, not even counting the potential or even the potential WISP that are on the same network, the interference problem keeps growing exponentially until you hit a limit where just adding one more subscriber or one more sector, let's say this way, can cause that your whole network will be dysfunctional. And the same principle is valid for bug holes. Regardless if you use a dish antenna or a patch array antenna, the side lobes of these antennas are inevitably leading to consistent degradation of wireless network throughput, and even more so in case of the unlicensed 5 GHz networks where your competitors also use the same antennas as you do. So using the antennas without side lobes and being with fitting the coverage scenario is the true solution to the problem of interference that we're facing today. Because let's say it this way, when you don't collect noise, then you don't have to deal with the consequences of it. So, and if you only cover the area that you really need to, I mean the necessary area, then you're doing the best thing you can do to increase your customers' satisfaction. So let's say it this way, if we replace, let's say this example on the screen now, if we replace even just one patch array sector in a specific tower for horns to try if horns really work, then we will see, as this example on screen, we will see a significant change in the performance, not only because the horn sectors will perform very well, but also the remaining patch array sectors on the same tower will also improve. So this can be a little bit counterintuitive because, and sometimes also confusing thing about horns. So they provide better performance because the horns, they lack something, and is in this case is the lack of side lobes. So we can go even and take it a bit further or a step beyond. The biggest gains in the total network throughput and stability are visible when all the patch array sectors are replaced with horn sectors. So when we remove from our tower the resources of noise, then every sector, each of the sector we have in our tower can perform or can function very near the maximum throughput the radio can handle, regardless which one you use, which any platform you use. So basically, we will stop worrying every day. So let's not touch anything so that the network doesn't crash, and switch to a thought that, wow, little to no noise, and I can keep adding customers without any problem. This is a real possibility that you have in your hands, and all of this is basically, you can reach it by using horns. The other scenario I presented before in the point-to-point links, so let's say we replace here one of the dish antennas with a highly directional horn antenna in an area that is very noisy. Overall, the throughput, of course, will increase, and you'll introduce also a high stability or a huge stability in your network. The modulation rates will not only be high, but they will also be consistent, which is also something that we need during any time of the day. So the point-to-point links that are based on horn antennas are very stable, and this is how horns work, unlike the traditional patch array sectors we're used to see on different deployments. So the real magic happens when you only use horns. So if we don't have no side lobes, this is equals to no noise, which is equals also to maximum performance. Sometimes WISP who start using horns on their networks are very happy with the performance they're seeing with the antennas. So they want to keep this to themselves and don't tell to anyone that they're using these antennas to keep, let's say, an advantage over their competitors. The fact is, though, if your competitors are also using horns as well, it will be very good for you as a WISP as well, because the less noise that everybody generates is the best for everyone at the end of the day. So if we wonder, or if you're wondering at this point, how densely can we install the horns and still deliver on the promise? So, well, I think that these pictures, these 3 pictures you're seeing on your screen right now, can have a clear answer. So it's many, so lots of sectors coexisting on one tower with excellent and stable performance at the same time. So this is truly unbelievable. With horns, we are used to seeing this every single day with different customers. So this is a daily reality. And this take into consideration that these pictures are not our own pictures. These pictures are pictures from our customers. Horns are the toolset that allows you to respond and adjust to the network to any situation you might face. On the left, as you can see on the picture and right images, we see 6 ultra horns covering distant narrow sectors with 15 degrees being with covering one sector each. In the middle, you can see a cluster of different being with horns. The versatility that this toolset provides to you, the versatility of the scenarios you can face or you can cover, it's really unmatched for when you're using horns. So you can already sense why we have 7 different symmetrical horns and 3 asymmetrical horns, plus a high gain narrow being with ultra horns, which you're seeing on this picture as well. The varying gain allows you to plan your network depending on what you actually need. So every situation is asking for a specific tool. For example, for dense co-location or dense customer base near the tower to the site of deployments, usually you can use a low gain horn for this kind of scenario. But let's say if you have a huge amount of customers all piling up or clustered far from the site, then the ultra horn with its narrow beam width of 15 degrees can be really the right solution for this scenario. For any and every situation in between these 2 scenarios I have mentioned before, you have the rest of the horns to choose to deliver the customers the quality of service that they are requiring, and a service that the customers do not have to worry about. If you want to know more about all of our products, then we have a recording of the product introduction webinar on our YouTube channel. So you can visit us by searching our filaments in the YouTube channel and basically taking a look at this presentation where we describe each of these set of products in a very detailed way. If you want to know even more as well of our antennas, including the adapters that we have, the twistport adapters, for which twistport adapter you need for what radio to be used in your WISP network, then please also check the recording of the product introduction on our YouTube channel. Again, we have here all the detailed information of each of our products, each of our series of products in a way that you can get all the data by watching it, and also you can get back to us in case you need some further information. So we have also a link calculator, which is the tool we provide free of charge to the public, to people who want to deploy, to basically plan their deployment. It's easy accessible on our website. You can log into rfelements.com, and then you will see a tile on the main page which says link calculator, and then you can access this calculator and basically start planning even your point-to-point link or your point-to-multipoint link, and also basically play with the antennas in your specific area of coverage to see how it will perform. The WISP commonly use the radio output power adjustments to control the coverage area, and this way also to, let's say, control the amount of noise that they're transmitting to any neighboring links, which makes perfect sense and help with the noise that a given link produces. But as you can see on this animation on your screen right now, decreasing the output power of the radio does nothing to the noise received by the access point from competitive links for other competitors nearby your area. This is an important point that we should understand. Adjusting the radio output power will only get you limited improvement over your network. To deal with the noise more efficiently, you need to adjust the reception area as well, and this is by using an antenna with lower gain. Doing that, the reception area, as you can see on this animation, shrinks, which mitigates the noise that the access point is seeing at the moment, and then you can maximize the performance. So this is another great strength of the horns. So we offer low gain horns as well as high gain horns, so you can react to the surrounding interference situation accordingly and optimize your network at the end of the performance of your network. So counter to the common thinking that some people might experience, lower the gain of the access point antenna can be a better solution. So far, I have been talking about antennas and as having a lot of side lobes in case of the patch array sector, or having no side lobes in case of the horns, which is rather vague at this point. So we might wonder, okay, is there an antenna parameter that can give us a quantitative measure of the amount of side lobes one antenna might have? Well, yes, it's called beam efficiency. You're seeing it also on your screen right now. Beam efficiency is, the definition is that it's a parameter that is able to quantify the amount of side lobes one antenna might have in a specific. So what's the meaning, no? Right. So it's the ratio of the main lobe energy, or the total energy of an antenna, which is radiating. So the maximum beam efficiency that you can achieve is 100%, in which case the antenna has 0 side lobes because 100% of the energy is being radiated into the main lobe. So the closer to 0% the beam efficiency is, it means the more side lobe an antenna might have or can have. So let's take this basic definition and let's bring it up to a practical example. Here you can see the radiation pattern of a generic parabolic dish. It means its beam efficiency, as you can see here, is 40%. So it means that 40% of this power the antenna is radiating, it goes into the main lobe. So the remaining 60% of the power of the energy goes somewhere else. And since everything outside the main lobe is considered a side lobe, then it will go to the side lobes. Please note that all the side lobes on this parameter are highlighted. So the beam efficiency introduces all the side lobes, includes all the side lobes of an antenna, unlike front to back ratio or other side lobe metrics you maybe know at this point. Beam efficiency is the ultimate side lobe measure because it's the most complete. It takes in consideration the whole radiation pattern of the antenna. With the beam efficiency, the comparison of antennas in terms of the side lobe performance becomes extremely simple. The higher the number, it wins, basically. So you can see here, the ultra horn on the left has a beam efficiency of 99%, which means that only 1% of the power it radiates is on the side lobes. A generic dish antenna on the right has a beam efficiency of 40%. So the remaining 60% is an energy that is going somewhere else, is going to the side lobes. 99% is clearly more than 40%, which means that the ultra horn is a better antenna in terms of the noise suppression and probably the best on the market. So the vast majority of antennas used for sectorial coverage in WISP networks are either patch array or horns. The patch arrays have many frequency-dependent side lobes, so the beam efficiency values are typically around 60%, depending of the manufacturing and also the design quality. The RF elements horns, when I mean horns, I'm speaking about symmetrical and asymmetrical horns. They have a beam efficiency of between 90 to 95%. So you can see other horns in the graphic as well. This is to highlight that it takes considerable effort to design a horn antenna such as that has a high beam efficiency. The stable and zero side lobe performance is not a given, but we put huge effort into our antennas to have a beam efficiency of at least 90%. And if we go similar to the point-to-point antennas, the patch arrays are again at the bottom of this image, of this animation, in terms of the beam efficiency performance, due to the many frequency-dependent side lobes they have, which are collecting and transmitting noise, hurting you and every other WISP network around you. So dishes are somehow a little bit better, and generally, it's the bigger the dish, well, okay, the better the beam efficiency performance. But this is also if it has been carefully designed and well manufactured. What is interesting, though, is the ultra horn. As you can see, it has 99% beam efficiency over the whole bandwidth of operation and both polarizations. The beam efficiency of the ultra horn is practically perfect. Only 1% of the RF signal is in the side lobes. So if you ever wondered if the ultra horn is worth the extra cash compared to a dish, then I think at this point the answer is very clear. With 99% of beam efficiency, it's probably the best performing antenna on the market in terms of noise suppression. So to make it easy also for the users of our antennas, for the people who check our antennas as well, we added to our datasheets the parameter of the beam efficiency with its percentage. So we are a really transparent manufacturer, and we want to provide our customers the information that is important and relevant to them. Maybe other manufacturers do not show the beam efficiency in their datasheets, on their antenna datasheets. Well, they all listen to you carefully. So if you keep asking for it, eventually they will start adding it as well. So 3 rules to a successful noise rejection are: let's use antennas with high beam efficiency. The higher the beam efficiency, the less side lobes an antenna might have. So the lower the noise floor and eventually higher network throughput. Second point, choose the right beam width and gain for the job. The wide selection of horns beam width makes it very easy to pick the right antenna for the job that we truly need to complete. And the third point in this slide is, let's adjust the gain of the antenna, of the access point antenna, according to the scenario we're facing. The adjustment of the radio output power has only very limited benefits. So I also take this opportunity to invite you to our forum, RFE Lab. You can ask basically anything here about our antennas, or even search through the questions that are already there. It is a great resource not only for questions, but also where we put a nice, or let's say a huge amount of content, like recordings of webinar, such as this one, or other media like radiation patterns for various simulation tools. Another source of information we constantly are working on is our YouTube channel. We have a playlist called Wisp Traveler, where Wisp, like yourself, they talk about their experience with horns and what problem they're facing and how horns have helped them to deal with these issues. We have customers from all around the world, so I encourage you to check out how your fellow Wisp are dealing and are using our horns. On the same channel, we have another playlist, which is called Inside Wireless. This is a series of videos with very educational content. We are constantly updating these videos with new topics, topics that might be interesting for you to know. Topics, of course, of the world of RF engineering. So regardless if you're even an RF veteran engineer or a complete beginner, these videos, they offer a great resource for anyone who wants to join or who wants to learn or refresh their RF knowledge in a very simple way. So that's pretty much it for this presentation. We have here the links of our social media platforms where we are present. So I guess now we will take the opportunity to reply to the questions that had been basically written to us during this presentation.
Okay, Jorge, thank you for your remarkable presentation. Your presentation makes us realize a lot of things here, especially the option of antenna that we must use in the particular situation, you know.
Yes.
Like,
yes, of course.
Like this is my experience in Indonesia, especially. People always use omnidirectional antenna. So the main focus there that they want to transmit or they want to cover a lot of client there. It's in the radius of the antenna, but
Yeah.
that we don't realize that the omni antenna also very prone with the noise.
Yes, it's a signal traveling everywhere,
Yeah.
360 degrees, so it's capturing signals from all around.
So they transmit all around and also receive from all around.
Exactly.
Okay.
Exactly. That's the trick.
Okay.
Yeah.
Yeah. So that's what makes us realize that omni antenna is not all, you know, like
Not the best choice.
Yes, not all condition choice. So
Exactly.
every situation we can use omni antenna. Every condition we can use omni antenna. But actually we cannot use that antenna in every situation, right?
Exactly. Yeah. Especially in today's networks, which are very polluted.
Okay.
So it will be more than a problem rather than a solution to the people using the omnidirectional antennas.
Okay. So we collecting some of question here.
Of course.
And I got question from YouTube here. So this is a question from Diki Alamsyah. He asked about how the horn antenna performance is it affected with weather, like in heavy rain or something, like fog.
With weather. Okay.
Yeah. With fog.
Okay. Well. Well, any antenna will suffer under weather conditions. At the end of the day, where we are transmitting over the air is electromagnetic wave,
Yeah.
which they suffer from different phenomenons, from physics phenomenons. And when weather, for example, rain can provoke a signal decrease on the CPEs that are connected to an antenna in particular. But the radiation pattern and the let's say the highly focused radiation pattern of our antennas can also be let's say a positive things under this scenario. But the performance will be degraded when it's weather, when it's snow, when it's high rain or very thick rain. It will be affected because again it's a radio frequency, and what we're transmitting over the air is electromagnetic wave, and they will suffer from these conditions because they will not be correctly able to propagate from the access point to the CPE. So degradation of the network under these conditions will always occur. It doesn't matter what antenna you use.
Okay.
Of course, if it's lower frequency antennas like 2.4 or even gigahertz or less, well, because of the wavelength of the antennas, they could be able to get better to the other end of the user on these conditions. But 5 gigahertz antennas, we have seen it before, they will always suffer under these conditions. We have seen in heavy snow, thick snow scenarios in mountains that when you have the ice storm, the antenna gets covered also with snow, and then the problems start with the signal dropping and therefore the throughput. So nobody can guarantee that 100% performance under these conditions. It's just not being able to do it due to the physics of the antennas.
Yeah, so there is physical law.
Well, there are physical phenomena of the electromagnetic wave when they travel through the air, like reflection, for example, on surfaces. Absorption also when the rain, because at the end of the day is water in the air, and it absorbs the electromagnetic wave and also decreases the signal strength that you can see.
Okay. And then we have also a question. Actually, a question from me. Yeah.
Okay.
You have wait. I will pick one of these.
Yes, of course.
Okay. So antenna is a manipulation of the wave, right? So this horn antenna, could you explain it more? How they can perform quite much better than other antenna.
Sure, of course.
You mean I mean that how this manipulation can be so great or can be so significant with the wireless, or you can say that this manipulation of the radio wave, something like that.
Yeah, well, on the part of the radio frequency of the antennas, of our antenna, horn antennas, they're really designed to be very optimal in the radiation pattern, which means that they will propagate the signal to where it's supposed to go, depending, of course, on the beamwidth of the antenna. Also, the lack of side lobes, which I explained before, is very important, because if you don't transmit signal to different locations first where you don't need, then the radio will be able to work with a better signal to noise ratio, and therefore it will be even a better throughput that the radio can achieve. On the twistport ecosystem side, well, the benefits, you can see them from a mechanical point of view or from a radio frequency point of view. From the mechanical point of view, the installation of the radio is very easy. It's even done with one hand. It says twist and lock mechanism, and also it's very easy for the people who jump to the towers and they want to replace perhaps one radio platform for another. It's very simple to replace a radio with an adapter in our antennas. So the less time somebody spends on a tower, the more safe at the end of the day they will be as well, right? And from the radio frequency point of view, basically the waveguide part, right, of the twistport ecosystem is also something that we really encourage people to use, because if you remove these pigtails from the picture, let's say it this way, then you remove a source of loss that the radio can see as well. Then if you attach directly the radio to the antenna with the twistport adapter, you might be able to also increase as well the throughput and the capacity that the radio can work with, because it will be more optimal. Let's say it this way. The radio produces energy, right? So you feed it to the antenna is the one who propagates the signal, right? If you're able to optimize how the radio delivers this power to the antenna, you will also be able to extract more, take advantage of this capacity of the radio. Then at the end of the day, you will also achieve a greater connectivity. So if you put the excellent radiation pattern combined with a twist port ecosystem with the near zero loss or zero loss, then you will achieve also excellent performance. And it's what we have seen over the years with the different deployments that people have done. It's like night and day difference on some scenarios. Of course, it's very important to take into consideration which antenna are we need for what scenario, which is something also I took the moment to explain on this presentation. But regardless, the radiation pattern of the antenna is well optimized. It propagates the signal where it should be. So you limit also the amount of noise the radio sees, combined with the zero side lobes that basically you will have an excellent performance on the terrain, on the ground. Let's say it this way.
So basically, the twist port is a solution for the reduce the loss that usually we got from the cable and everything. And from the connector, we can achieve more efficiency.
Exactly.
Yes. From this twist port adapter. Yeah. So RF already have the starter twist port, something like this. Yes, and then also the twist port adapter for the
SMA.
Yes. So this is for the big one, like here. I think it's the principle is the same, right?
Exactly. The principle is the same.
Okay, but different material.
No, different materials, and not the difference of materials. It's rather that the focus of the starter antennas is a little bit different. The starter antennas are meant basically for people who want to break the ice with the antenna technology of RF elements at basically at a price or affordable price that they can test
but
how
the
it
principle
performs.
Is the same, yeah.
Yes, principle is the same, exactly. Yes.
Okay. Then there is also a question from YouTube. Okay. Right now, RF element give us option of horn antenna. There is a symmetrical horn antenna, something like this, and then asymmetrical horn antenna, something like this. So the question is, do you have any guidance or specific example when or what situation that we must use the symmetrical and what situation we must use the asymmetrical?
Yes, of course, like typical scenarios.
Yes.
Well, I mean, let's start from this way. Symmetrical, I mean, the word speaks for itself. It means that the aperture or the beam width of the antenna in both polarizations, horizontal and vertical, are exactly the same. So the radiation pattern that it projects on the terrain, it's like a cone. So when we go to the asymmetrical, also like the word speaks by itself, right? The aperture is wider in the horizontal plane compared to the vertical plane.
Okay.
So the radiation pattern is different on the terrain as well. So, for example, typical scenario is a mountain where persons have a tower on top, or a hill, a tower on the top, and they want to cover the clients in the valley down the mountain, right? So on this kind of scenario, asymmetrical horn would be more useful because of the aperture in on the vertical polarization. The asymmetrical would not be that optimal because it has narrower beam width on the vertical plane. Therefore, exactly, it cannot cover properly all the clients that are down in the valley. So this is something that we usually see. For example, asymmetrical horns are very good when we are in rural areas, when clients are far away from tower, but they are also spread
Edit, yeah.
exactly over a huge amount of terrain. So that's where the asymmetrical horns they shine.
Okay.
But of course, every scenario is different. Every deployment zone is different. So it's very important to analyze in detail the terrain where we're going to deploy using also our link calculator. So we can really make a good decision if to choose an asymmetrical or asymmetrical antenna. Scenarios, there are many. We will need to study in particularly each one of them to see what we can recommend.
Okay, so the main focus on the vertical, right? The vertical beam width. The difference, only the vertical beam width, right?
From the asymmetrical horn, we have three models,
Okay.
right?
Okay.
30, 60, and 90. So the aperture is 20 degrees on vertical in the asymmetrical 30. But if we compare for the symmetrical 30, for example, it would be 30 and 30. So you have 10 degrees even more aperture on the vertical plane, which can help you when you're going to deploy, for example, in these kind of hilly zones or mountainous zones.
Okay, okay. Thank you for the explanation. And then next question. Yeah, it's basic question. Yeah, basic question. Could you explain about the front to back ratio?
Well, the front to back ratio is a metric that measures the side lobe, the main lobe versus the back lobe.
The efficiency?
And this
No?
Well, beam efficiency is a parameter that takes into consideration all the side lobes of an antenna.
Okay, okay.
And the front to back ratio only takes into consideration the front and the back lobe. So at the end of the day, you're not seeing the whole picture or the whole performance of an antenna. It's a very limited information you can see with the front to back ratio. The beam efficiency is a parameter that is more complete in this sense because it takes into consideration the radiation pattern, the whole 360 degrees of the radiation pattern of the antenna, and it takes into consideration every side lobe, and it gives you a number in a percentage, right? That percentage will tell you how good an antenna can suppress noise or not, due to the basically the noise reduction that it can achieve. So really, front to back ratio is a metric that is not so useful and or doesn't give you the full picture of an antenna. So that's why we are encouraging people to take into consideration the beam efficiency, because it's a more complete parameter when we're trying to figure out if an antenna will perform better under a noisy area, for example.
Okay, and then okay. So this horn antenna, symmetrical or asymmetrical? So they can install in the same tower, right? Or
yes,
or we have special rule for if we use the asymmetrical, we must use the same asymmetrical on the tower on that side, or we can mix between the symmetrical and also the asymmetrical.
Yes, of course you can mix, and that's the idea, because perhaps the scenario is different on when you look on an angle of a tower, the terrain is different, so you can combine different aperture of horns, being symmetrical or asymmetrical, to really give coverage to the clients that are on the terrain. It doesn't mean that you need to use only 90 degrees or only 30 degrees.
Yes.
You can start by 90, and then you can even play a little bit and say, okay, now my sector of 90 is too dense, and I need to replace by 160 and 130, or 330s, or 140 and 150. So this is like the play that people can do with the toolset that we provide to the industry. So yes, they can combine asymmetrical and symmetrical horns, basically to give personalized, let's say, coverage on the area.
Yeah, depend on the situation, right?
Exactly. Every deployment zone has a really specific thing that we should take into consideration when we're planning a deployment.
Okay, then there is another question here.
Sure.
Okay. How about the installation? Is it easy to install, or there is something special need to prepare to install?
Our brackets, as you can see there in the tower you have next to you, are very simple to
something
install.
like that. Or like
yes,
this, yeah.
Yeah, we work really to make the life easier also for the people who go on the tower. So we think about every little detail that can be adjusted to make the installation more easy. On the latest antennas that you have there, the asymmetrical horn, we have the universal bracket, the UBR. Well, on the asymmetrical 60 on top. So this is really and the new bracket we have designed, which is more robust, which has also the stainless steel black coated screws to avoid the seizing, which is a issue we have seen in the past with this kind of material. So we're always thinking constantly of how to improve our mounting solutions, not only to make it simpler, but at the same time robust and durable. So we also think about the materials we use, the high quality materials for durability as well. So it's very simple to install. We have the videos on our YouTube channel on how to install. It takes very short time to achieve the installation of an antenna in a tower. Basically, you put the two sides of the bracket and then you just slide the antenna in the case of the asymmetrical horns, and it's quite simple enough to install in tower. Only a couple of bolts, and then you need to adjust the azimuth and elevation planes, and it's good to go. All is done with a 13 millimeter wrench.
Yeah, you also provide the tools.
Yes, we have also the 30 millimeter wrench. It doesn't come in the box, but yes, we have them separately.
Okay. Yeah. The bracket it's very good. I remember that there's a line that you built like a tank.
Yes, exactly. Yeah, solid antennas.
Solid antenna, yes. Solid bracket, and also you also focus on the material, like the bolt that you say that it is
it has a black coated surface,
yes, so
to avoid the seizing of the material.
Okay. How about there is a question that what type of client that's suitable or that has performance, maximal performance if we use this type of horn antenna? Is it can be used for the for connecting another wireless like outdoor antenna, something like this, or is it also can be used for various of client like laptop, like a phone, or like other equipment?
Well, it depends mostly first on the radio you're using and what kind of protocol it's using. For example, Ubiquiti with the Prism, they have the Air Max, which is a proprietary technology, and devices like phones and computers will not be able to connect. But if you use a radio, any kind of radio that has a pure 802.11n or AC protocol, of course you will be able to connect. These antennas, they work under 5 gigahertz.
Okay.
So any device who works on 5 gigahertz, it can technically be able to associate with this antenna, but it will depend on the radio platform you're using on the side of the access point. That's why it's very important to choose a device that doesn't have, or at least has the ability to disable the proprietary technology they use for the access point. So if you use, for example, we have seen it before, TP-Link radios, with pure 802.11 AC. The people use them usually a hotspot with computers, laptops, and phones, and it works perfectly. It's no problem with that. Yes.
Oh, so we actually it is focused on the frequency, right? Because this antenna working from this frequency. So every device that can that use the same frequency, it can be connected with this.
Can be used with the antenna, and then of course on the side of the side of the phone or the computer, it has to be able to use those frequency too. So perhaps you will need, there are phones who come with this 2.4 and 5 gigahertz chipset, computers as well. If not, then people will need to get some additional dongle, USB dongle for Wi-Fi, basically.
Okay. Are there any limitation for how many maximum client can be connected with this to this antenna?
There is no limitation in that sense because the antenna is a passive element of transmission.
Okay.
It doesn't limit the amount of client you can connect or associate. Who does this limitation is the radio platform you're using and the capability of this radio to process X amount of clients. So no, the antenna will not define how many clients you can connect. It's all about the radio. But the parenthesis and the important thing here is that an antenna that is so efficient with the radiation pattern on the side lobes, with low side lobes or zero side lobes, then you will be able to squeeze more the power that a radio can produce, and therefore be able to get maybe more customers. But again, the antenna will never limit the amount of CPEs, for example, you can associate with the radio.
And how about the range? The signal range,
The range.
How long
it depends on the model of the antenna. It depends on the tower height. It depends on if there is clear line of sight. It depends on what gain has the CPE. So it's saying a number or a fixed number for this kind of reply. It will not be a good practice because it can vary so much. It depends also what people want to deliver to a customer, because some people, they want to sell only 10 megabits. Some people, they want to sell 50 or 100. So it will not be the same, the distance they can cover. So what we encourage the people to do is to go to our website, simulate with a link calculator.
Link calculator, yes. You already have that tool.
Yes.
It will help people to actually to decide which antenna that they can use before they really deploy the network.
That's the idea, plan before you deploy, so you make the correct decision on which antenna to use.
Okay, I think that's all question that I got from YouTube and also from Zoom.
We have the discussion group, as you know, on Facebook as well.
Oh, yeah.
So anybody who wants to join the Our Filaments Asia group, we are free to do. We are also interacting there every single day. So any further questions that people might have, please just go to Facebook, search for Our Filaments page, and then you can see all the groups associated to that page. Write your question, and we will reply with all the necessary information that somebody might need.
Yes. You also have the YouTube channel that you explain a lot of things about wireless.
Yes.
And how to install, unboxing, and
exactly.
A lot of things that we can learn from your YouTube channel.
Yes, we have the YouTube channel. It's a very useful way of communication that we are constantly updating with new content. We have their installation of antennas, how to install unboxings, and we have all the recording of the webinars in many languages as well. We have there the WISP Traveler series, in which we go and visit WISP who are installing our antennas, and we get the feedback firsthand on the performance. So this is very useful information, educational information too, that people can take some time to look at it and to learn, and to also make better decisions when they're planning their next network.
Okay, Jorge. I think the time is up for us on this event, and thank you once again for your time. You can join for this event, and maybe we can do same thing next time.
Yes, of course we can. Definitely, we're open to any kind of cooperation, and to teach the people, and basically give presentations that will be really useful for them. Definitely.
Okay,
so
Jorge.
Thank you very much.
Yeah, thank you.
And have a good day.
Yeah. Okay. Bye.
Bye. Thank you.
Oke guys, itu tadi presentasi dan beberapa interaksi tanya jawab, banyak sekali pertanyaan yang datang memang dari teman-teman di YouTube maupun yang ada di Zoom. Jadi mungkin teman-teman sudah mendapatkan jawabannya kenapa harus pakai horn, kenapa beam efisiensi itu penting, kenapa noise reduction itu penting, dan memang tidak ada satu antena yang bisa digunakan di segala situasi. Ya, jadi antena horn ini memang diciptakan untuk untuk memberikan pilihan bahwa efisien untuk kondisi tertentu itu bisa menggunakan antena horn atau juga bisa menggunakan sektoral array seperti ini, dan juga bisa juga menggunakan yang solid seperti ini. Jadi tergantung dari kondisi atau situasi di lapangan seperti apa ya. Kemudian buat teman-teman yang belum subscribe, silahkan teman-teman subscribe. Jangan lupa klik lonceng. Oh iya, kita juga masih punya promo ya. Jadi teman-teman jangan khawatir, kita masih punya promo mingguan dan juga ada promo lagi apa Min? Oh, free ongkir di Pulau Jawa juga masih ada. Jadi teman-teman yang setelah melihat penjelasan mengenai RF elemen ini dan ingin mencobanya, silahkan teman-teman bisa langsung aja belanja di citraweb.com ataupun di marketplace ya. Di marketplace kesenangan Anda teman-teman yang punya voucher diskonnya ya. Kita punya beberapa marketplace, kita sudah ada di beberapa marketplace di sini, jadi teman-teman bisa langsung pilih yang menarik, promonya yang mana. Kemudian ada juga di promo-promo mungkin minggu depan ya kali ya. Ya, minggu depan juga ada promo mengenai ini antena. Jadi ada juga beberapa produk antena RF elemen ini masuk di promo. Kemudian kita juga mulai membuka kelas training buat teman-teman yang sudah nggak sabar. Kemarin banyak yang tanya, Pak kapan trainingnya dibuka lagi? Kita sudah buka, jadwalnya sudah ada di citraweb.com/training.php. Teman-teman bisa cek jadwalnya di situ buat teman-teman yang tertarik untuk training secara langsung ya, tatap muka ya ini ya. Ya, itu bisa lihat jadwalnya, dan memang untuk training yang tatap muka ini memang kita mengadopsi protokol kesehatan. Jadi kita mematuhi peraturan dari pemerintah untuk mengaplikasikan protokol kesehatan di training kami. Ya, jadi segala persyaratan, misal dari harus ada tes swab dulu dan segala macamnya, itu detailnya itu ada di halaman tersebut. Jadi teman-teman yang mau training, tertarik untuk training tatap muka, silahkan cek halaman training di citraweb.com. Oke, sekian dari saya, dan terima kasih buat teman-teman yang sudah meluangkan waktu untuk join di YouTube live kali ini. Jangan lupa untuk tetap patuhi protokol kesehatan dan jaga selalu kondisi teman-teman semua supaya tetap fit, dan patuhi selalu mengenai protokol kesehatan. Oke guys, sampai jumpa di YouTube live selanjutnya.